YouTube. This is my third video on analyzing graphs of functions, in which we're going to focus on increasing and decreasing and constant intervals for graphs. And in terms of increasing, decreasing, or constant, really, for example, when you look at this graph here, it's kind of easy to read this from left to right and kind of look at it and say, well, you know, from here to here it's decreasing, and then it starts to increase again, and then it's decreasing, and then it's increasing. And even over here on the right, this function here, we say, well, from here to here it stayed constant. But what I want to do is I want to kind of start by defining what we mean by increasing, decreasing, constant. And so we're going to start with the increasing here. If a function is defined as something that is increasing, we're saying that on an interval of x values, let's say it is implied that x1 is less than x2. And basically what this is saying is, given some function here, that on the x-axis here we have an x value that is x1 and x2, and x1 is to the left of x2. Basically what we're going to say is, if this were to imply that f of x1 is less than f of x2, purely less than, not less than or equal to, basically what we would be saying is this. We would say that the y value at x1 is less than the y value at x2. We could say we have some function that maybe does this. We could see that we would have a function that is implied to be increasing. Likewise, if we said, well, what if I had a function that I cared to have be decreasing? Well, then we would say that given two x values, x1 and x2, on some interval of x values here where x1 is to the left of x2, we would say our function would be decreasing if the y value at the first x value is actually greater than the y value at the second x value. That is to say that if I were to have x1 and x2, then we would say that the y value at x1 here, f of x1, is greater than f of x2. So this would be a decreasing interval. And then as far as constant goes, we would say that given two x values on an interval here from x1 to x2, if f of x1 were to be equal to f of x2, that is, they are at the same height, then of course we would have some graph here that if x1 is here and x2 is here and x1 is to the left of x2, we would say that if this y value is the same as this one right here for all, x values in between, then we would say that this would be some constant in interval here. So what we're going to do is we are going to determine the intervals over which the function is increasing, decreasing, or constant. Now the interesting word here happens to be intervals. And we saw interval notation when we talked about domain and range. So what I'm going to ask us to do here is to identify on the graph, first of all, where this is increasing, decreasing, or constant. And I always tell my students, let's just go ahead and write it on the graph. We say that I notice that it's decreasing here. It seems to be increasing kind of in this little section here. It's decreasing over here, and then it's increasing here. The problem is that they want to write the interval of y values for which our function is increasing, decreasing, or whatever. So what I kind of mean to point out here is this. For instance, you'll notice that this is a y value of 3 here. This is 0, 3, and that this is the point 3 comma negative 3. But I get a lot of students that like to tell me, well, this function is decreasing from 3 to negative 3. And what I'm going to tell you is when we talk about the intervals of values for which our function is increasing, decreasing, or constant, we are looking for the intervals of x values or inputs for which it is increasing, decreasing, or constant. So really what I would like for us to do is this. I would like to partition the x-axis up here and kind of split it up into increasing, decreasing, or constant intervals. So looking at just the x-axis here, for what x values is our function decreasing? You'll notice that our function seems to be, goes on forever and ever to the left here, and it goes up to the left. But as we read this from left to right, I notice that from way out at negative infinity up to this x value right here, and it looks like this x value happens to be negative 3, our function is decreasing. So what we're going to do is we're going to say our decreasing intervals, starting at this one on the left here, we say that the x values for which our function is decreasing is way out at negative infinity, so our left endpoint is negative infinity. You'll notice that I used a parenthesis here because it is not, it's stopping at it. It doesn't include negative infinity. It just keeps going on forever and ever. But the left endpoint of that decreasing interval is from negative infinity up to this x value right here. So we'd say on this interval of x values from negative infinity to negative 3, and you'll notice that I didn't include negative 3. It is decreasing. Now, why didn't I include negative 3? I want you to think about this. Why wouldn't I include negative 3? Is our function decreasing exactly at that x value? And the tough point here is basically this. It starts to go back to increasing here, and it was doing it from decreasing, okay? So this little point right here, we call this a cusp. and it's not a very smooth transformation, but we would basically say that it's not decreasing at -3, nor is it increasing. It's kind of just its own thing. So we are not going to include -3 on that interval. Now the interesting thing is our function also decreases from the x value 0 up to the x value 3. So what we're going to do here is we're going to say, well, it's not just decreasing here, but it's also decreasing in union with the set from starting at 0 up to the x value 3. So if we were to highlight the x-axis, essentially, let me switch colors here, we would say that our decreasing intervals would just be these intervals right here. On those x values, our function is decreasing. Now, where would be the increasing intervals? Likewise, we could say similar things. We would say, well, starting at -3, at an x value of -3, and going to an x value of, right here, our function is increasing. And that x value is 0. We would say on that interval, our function is increasing. And it's also increasing from the x value 3, not including 3, but starting at 3 and going on forever and ever to infinity. So on these two x-axis intervals, we get y values that happen to be increasing. And this would be basically all we would write for this function here. So let's go ahead and consider this function here. You can pause the video, try this one on your own. I'm going to go ahead and explain this. If you don't want to pause it, keep listening. But we would say that we notice that we have a constant section of the graph here. Our function stays constant. That is, for this x value over here and this x value right here, all y values were equal. So we'd say we have a constant interval from the x value, -5, all the way up to the x value 2. So from -5 all the way up to and not including 2, we have a constant function. Our y values are not changing. All of a sudden, though, you'll notice that we switch to a decreasing interval, and that happens between the x values 2 and 3. So between 2 and 3 here, we'd say we have an increasing interval. We'd say starting at 2 and going up to 3 and not including either of those, our function is decreasing. Sorry, we were looking at decreasing there. And then as far as increasing is this last part of the graph. You'll notice that this graph never stops going to the right, or it never stops increasing to the right of 3. So we say our increasing interval starts at, but not including 3, but it starts there, and it goes to the right. So our increasing interval would be 3 to infinity. Okay, so important things to take away from this video. When you have multiple increasing or decreasing or constant intervals, we use this u to represent a union of these intervals, or a union of those sets of numbers that would cause those. And also that we look for intervals of x values. We never report the y values when we talk about increasing, decreasing, or constant. Cheers.